All right, we're going to do a Rave physics stroll. It might be noisy for the next couple minutes, so feel free to skip forward in the video. I'll banter until I get off the main street so that I don't make people listen to the sound of cars going by just because they're trying to get something interesting out of Rave physics. But yeah, the topic today is going to be dimensions. So we're going to talk about dimensions. And we'll talk about the 9 dimensions in human design ontology. And I'll begin shortly. I'll banter a little bit. So we're on Agua Fria Street here in Santa Fe, New Mexico. I have this sunbrella. It's fantastic. It really, really, really helps. Oops. I also have a new phone, an iPhone 11, where I used to have an iPhone 7, and so viewer, hopefully a fan. Not everyone who's a viewer is a fan. Viewer Kate sent me a microphone a few months back, and it's really good. I've used it on every laptop recording since then. And I thank you, and my clients thank you, because they get the higher sound quality as well when I record off the laptop. Okay. Just a friendly neighborhood. Pardon me. Oh, thank you. It works so well. It works great. I get a lot of comments on the sunbrella. That was our neighborhood postal our postal worker. So yeah, having this iPhone 11, the audio is already a lot better even without the microphone, although the microphone is still the best. And of course, some things you can't avoid, like wind. Using a lapel mic, you can kind of mitigate some of that if you put it under a shirt, but I've just had so many problems with, I've tried lapel mics again and again, and I'm really hoping that this one that Kate sent will work well on this iPhone 11. I couldn't get it working on the iPhone 7, so I've been using it, only on the laptop, because no matter how hard I tried, the iPhone 7, I think I don't have the right kind of adapter, because I actually got the dongle, as they call it, the doodad, the the chimichanga. I got it, and but it still doesn't record. It doesn't ever recognize the mic. So I'm thinking that this iPhone 11 probably will. I think it's just that I had a much older iPhone, and it was right when they first switched to using. Sorry, I don't mean to make the phone so close. It was right when they first switched to using the new adapter type, the Thunderbolt instead of analog. Okay, we're actually getting off the main road now. I have just left Agua Fria back there. I'm standing on a nice little hillside. You can see the Sangre de Cristo Mountains over my shoulders. And wait, is that? There they are. Oop, there they are. Okay, yeah, that's the Sangre de Cristos back there. And let's get going. All right, I'm gonna get situated. Walking down a hill, juggling a few of my objects here. Okay, so this is my workout clothes. I'm on my way to work out. I work out in Converse and sweatpants and sweatshirts usually. It depends on the time of year, of course. Okay. Whew. This gets a little lift from the wind. Like I'm just walking along and then it kind of starts to take off. Okay, so Rave physics. We're starting with dimensions. I actually started writing a book a number of years back before I came to human design, about 10 years before even. I was in my mid-20s, early 20s even, and it was called Dimension and Surface. I've sometimes thought about trying to finish it. It's a philosophy book where I talk about dimensions and I talk about surfaces. They're kind of the same thing. It depends on the perspective. But in any case, it's a little dimensional joke. It's going to get really wacky today. Okay, so dimensions. The first 3 dimensions are pretty easy. Up, down, left, right, forward, back. So every dimension's a binary, first of all. It's binaristic, and it requires the binary. You need up, down. If you only had up, no such thing as up unless you have down. So dimension is already a binary. And the first 3 dimensions we have, what sets them apart and what I'm going to be using for my kind of definition of dimension here is that they are degrees of freedom. That each one is free in some sense, or is a degree of freedom, or I should say, maybe not degree, each one has degrees. Dimensions contain degrees within them, right? So it's more like they're orthogonal to each other. And, you know, we use the word orthogonal to describe 3-dimensional space, Cartesian space, but you can also see how other dimensions are orthogonal. And they also sort of reveal mutual exclusivities. So when we get into the idea of dimension, we're going to be kind of generalizing the idea of dimension from dimension as we know it to the 5 dimensions from human design known as space. See, human design is 9-dimensional. I mean, not human design. Our world, our Maya is 9-dimensional. But human design's ontology recognizes these 9 dimensions and names and discusses these 9 distinct dimensions and talks about the juxtaposition of 4 of these dimensions with the other 5 and how it's the juxtaposition of those and how the other 5 are not like the 4. We could almost call them atomic dimensions versus dark matter, dark energy dimensions. You know, not really, but in some, this is going to be, I'll go this way instead. I love this little park, by the way. This is one of my favorite areas. Very Santa Fe, just old barbed wire fences, old cans, old bullet shells. Datura over there. Datura is looking kind of wilted. Oh, this chamisa. So the 4 dimensions that we know are the Einsteinian dimensions, and already the jump from the 3rd to the 4th dimension is a little tricky because the 3 dimensions we have are orthogonal to each other, the up, down, the left, right, the forward, the back. But then we get the 4th dimension, and it's orthogonal to those 3, meaning it's a degree of freedom separate. Obviously, they're all interlinked, but the fact that they're interlinked doesn't mean that one depends on the other. It's not like I can walk forward, in Euclidean space and make time move forward, and then I walk backward in Euclidean space and make time move backward. It doesn't work like that. No matter how I'm moving in Euclidean space, I'm always moving forward in time. So, and there's lots of funny TV shows, probably a Red Dwarf episode or 2 in some, like Nod Nall episode, the London episode, where they go to Nod Nall, which is London backwards, and everything happens backwards. And you can see some of the funny things that happens when you start to play with these different dimensions or decouple them, how absurd it gets. How we just, always move forward in time, and then these other 3 dimensions we have create the effect of space. But what's interesting is, this is what I've always kind of learned, is that, the 3 dimensions are space, and yet now I'm realizing it's not enough. That the 3 dimensions, the 3 Euclidean dimensions, up, down, left, right, the XYZ dimensions, I should say, are not enough to make space. To make something have the effect of space, it has to be an acoustic environment, which really makes me wonder about people who are hearing impaired or even born having never heard anything, and what sort of inner hearing occurs. Because space is fundamentally acoustic and not a visual phenomenon. But in any case, or a volumetric phenomenon, I should say. I mean, I know it sounds weird to say. I guess I should say volumetric space is primarily acoustic, not visual. That's what I mean to say. That hearing is the sense by which we use to apprehend space. Whereas seeing is is something else. I mean, it seems like we're using seeing to apprehend space, and we are, but in some sense, the visual spectrum, the visual field is always being reduced to 2 dimensions, not 3. It's a 2-dimensional representation of a 3-dimensional field, which is why things get larger as we walk towards them. Have you ever thought about that? Side note, I love reading U.G. Krishnamurti because he talks about how his eyes decoupled and how from that moment on, it's an effect you actually can get if you play video games a lot. If you play Minecraft or if you play any racing game like Mario Kart, it's very easy to see in Minecraft. Try it. Play Minecraft, decouple your eyes, blur them, and then walk forward. What you'll find is, as you walk forward in Minecraft, the objects coming towards your eyes appear to be crisscrossing and zigzagging. And it's actually creating this kind of weird X shape where they collide with each other. The left eye and the right eye images, the stereoscopic image, collides. I'm sure there's a name for this phenomenon. Please feel free to post it if you know what it is. Oh my God. Sorry, I took this other way. I was trying to avoid some of that. So I'll take a break up here and drink some water and we can talk a little more about it. But thinking about dimensions then in this very limited sense of the term, which is not, it's more like generic, I should say. Limited in that it has limited application or value beyond the generic at this point. Like, I do think going deeper into the idea and looking at some of the other values, the multivalence of the term dimension, is very useful because you can look at some of the other ways the dimensions interact together. But I guess my point is, to start with, just think of dimension as, basically its own unique world unto itself, right? As soon as you have one dimension, you have a world unto itself. It can only go forward and backward. And we have one-dimensional representations. We still require a minimum of 2-dimensionality, but we can say that the second dimension remains constant, like a straight line. It's at a constant height, and then its width is going, and so we just have like one dimension effectively. Even though, of course, it also has a constant z. It has a constant. Two of the dimensions are constant because the level of the pencil lead is remaining constant too. We have to remember, if you draw a circle on top of itself with a pencil, you're actually making a spiral out of the, not pencil lead, of course, but the pencil material that they use. So what I'm trying to say is, we can imagine one dimension fairly isolated. We can't truly isolate it, but we can see that it does create a world unto itself. When you have a single dimension isolated, it is like its own kind of world. It's the world of, this is just a straight line, and you see it when you see like a wall, for instance, or you see it actually as the fundamental, Deleuze points this out as the fundamental gesture of the animal is the straight line. The animal makes the pose and makes I'm trying to think of like an eagle or like a snake or a cobra or like a, you know what I mean? It makes some, I don't know what pose, but it makes some kind of arm pose. Or think about military. Think about, Nazis would always do the Heil Hitler, or people would always do the salute, and things like that. These are straight lines. And what we're creating is the image of a straight line, is creating the experience of the one-dimensional world. I think it was Carl Sagan. Carl Sagan has the whole, dimensionality kind of story. It's great. He has the whole story of going from one dimension on. Drink a little water and we'll keep walking. So, and then you have 2 dimensions, and the 2-dimensional world is obvious. Again, the third dimension is just constant. It's the width of the sheet of paper. The 2-dimensional world is the world of art, of painting, of comic books, of graphic novels, of stories. I mean, it's the diagrammatic world, diagrammatic thinking. There's all these new books in philosophy on diagrammatic thinking and visual thinking. There's people like not Renee Zellweger, she's the actress, but somebody who has a very similar name to that created a visual logic. It'll come to me later. See, I haven't drank enough water. That's what it is. If you ever have a hard time remembering, it's likely because of water content. Oops. And of course, for some people, that's correct. If you have a, I gotta move this. If you have a sixth color determination dietary regimen, where your sixth color, you're either indirect light or direct light, then you probably won't benefit from drinking too much water, Excuse me, I gotta set this down for a moment. So we're gonna keep going on, setting it down. So we're going to keep going on this. So dimensionality, right? So we have the 4 Einsteinian dimensions. So you go through the first dimension, not really much there, but we see these kind of fundamental expressions from animals and things like that. The line, you have 2 dimensions, suddenly you have this huge explosion, the 2 dimensions playing off each other. We get to see that as soon as you have 2 dimensions that are independent of each other. They're independent, they have independent range of freedom. You can move left or right however you want on that XY grid, but within that independence, it's still limited, it's still finite, an aggregate of finites is still finite, as Bucky Fuller likes to put it. There's no infinity, really. It's just a limitation that gives the appearance of near infinite permutation within the visual field. And that's our 2-dimensional reality. And all of painting and art and so much of film. Film is shown in a 2-dimensional, it's a 2-dimensional representation. Although film, of course, requires the sound, particularly enhanced acoustic, improved to truly give the illusion. And VR is the same. When you have VR without sound or with sound, it's a big difference. And same with... So it is interesting for people who are hearing impaired. And I wonder if their inner ear generates an inner sound or an inner acoustic environment. Particularly if they have 4323. Which is about the inner ear and inner hearing. Okay, time to go further in our journey. So we have, and then you get to the 3 dimensions, and 3-dimensional stuff is like dance and sculpture, and we have these 3-dimensional art forms, but still not necessarily acoustic. Now we get to 4th dimensional. 4th dimensional also is dance, right? Because dance is movement. And the 4th dimension kind of is time in some sense. It is, the way that we can treat time as a dimension, as its own. So this is our first real split where we go, how do we move from 3 space dimensions to 1 time dimension? We've already made a jump. It's easy for us to understand the relationship of X, Y, and Z. But as soon as we get T in there for time, it gets a little confusing, right? So that's already a little bit of a jump. But then there's 2 more jumps coming. And the first is to the 5 dimensions of human design. And then the second of those 2 jumps is when you combine those 5 dimensions from human design with the 4 Einsteinian dimensions, 4 dimensions of relativity, what we could almost call the atomic dimensions. It's almost as if, the way I like to imagine it is the atomic world versus the dark matter world. And I love Leonard Susskind's thing about how black holes are like portals that take in photons of light, and for every photon they grow by a fixed amount because they are essentially saving the data that they have received. I would only modify, it's not necessarily photons, it's neutrinos, That'll be the really interesting thing when we see that it's neutrinos that are carrying the information into the black hole, which is then perhaps saving it, quote unquote, into the dark matter, dark energy side of things. If you imagine everything as a binary, the atomic on one side, the non-atomic on the other, right? And so we have atomic matter and energy, and then we have non-atomic matter and energy. Dark matter and energy. We can't see it. We can't measure it. Or we can measure its periphery. We can circumscribe it. We can't describe it. We can circumscribe it like a ship going around the perimeter of an island, not being able to go in past the event horizon. Because what's effectively happening, according to Susskind, is that, there's this very interesting mathematical property, which is that if you imagine every bit of data as a distinction, in the Gregory Bateson sense, whatever his name is, a difference that makes a difference. That's his definition of a distinction. And you kind of go into this laws of form territory, like George Spencer Brown, where you say, any distinction or any difference can be measured basically in a bit, as a 1 or a 0, as a yes or a no, as a yin or a yang, as a broken or unbroken line, however you want to look at it. And so these distinctions can be measured in bits, and what it turns out is that actually the smallest unit of measurement, the Planck scale, or Planck, however you say his name, Planck, the Planck units, as we say in America. When you measure at Planck units, what you find is you can actually perfectly describe everything inside of a volumetric space, which is to say inside of a space, like inside of a house, by simply measuring the amount of Planck units on the outside of that house, the fully outer boundary, and then using that amount of distinctions. And it's somehow possible, it seems insane to me, but it is somehow possible to describe everything within that space, i.e. every point within that space to a meaningful level by using the number of Planck units of the outermost boundary of that space, the outermost surface, in other words. Interesting idea, right? If you take the outermost surface of the Earth and you measure the amount of Planck units in that outermost surface of the Earth as a sphere, let's go all the way out to space. Let's go 20 miles, whatever, off the surface of the Earth. You take that sphere, you count the number of Planck units that you could fit on the surface of that sphere. It's that many distinctions that are necessary to describe everything, the state of every atom in the entire Earth. It's a bizarre idea. It's like in computer programming that you could describe the state of something. But it makes sense from a computer programming perspective, almost, in that it does take a larger amount of memory, in the sense that the outer surface will always be it'll use more data. So it's not that we're not saving on compression here. We're actually using more data, or we're using exactly the amount of data that's inside of it in terms of distinctions. But in any case, this mathematical quality that the outermost shell of something, the outermost surface of a sphere around something, can be measured how many Planck units you can fit on the surface of that sphere, and then that's how many distinctions you need in order to fully describe the entire contents of that sphere, everything down to the center of that sphere. The entirety of the contents can be described in the amount of bits, from the outermost edge. So what Susskind does then here is he goes, okay, well, because of this, we know that the outermost edge of the black hole grows, that the surface area of the black hole grows in size. And it's growing, it's like what I think of as one of those machines at an arcade or a carnival where you put in the quarter, and the quarters all create a lattice of quarters, and they all push. And what's interesting is, what he's saying is every new photon that hits the black hole causes it to grow by a Planck unit. And that Planck unit is sort of saving the data from that photon. I would add saving the data from the neutrinos. I believe, I hypothesize. I don't believe, but I wonder, if that's the case. Or I propose that it might be. Because as this information carried by neutrinos, or however the mechanism of carrying hits the black hole, it's like the quarter going in the machine, where it pushes all the other quarters ahead or pushes them over and so on. But instead, you can think of this lattice of quarters as these bits, as these ones and zeros, right? And of course, they wrap around in three-dimensional space from our perspective. But here's what's interesting. From the other side, from the non-atomic side, there is no three-dimensionality. What Susskind says is the black holes are saving all the information that comes to them, and they are saving it as pixels, not voxels. They're not volumetric pixels. They're not three-dimensional. They're two-dimensional. They're two-dimensional. It's a really interesting statement that Susskind makes here, where he points out that it's almost where the two-dimensional and the three-dimensional meet. But I would say where the atomic and the non-atomic meet, and that the non-atomic is, in some meaningful sense, no longer three-dimensional. But it might be two-dimensional. They might legitimately be pixels, not voxels, right? Okay, so moving on, the 5 dimensions in human design that human design contributes. These are the 5 dimensions that are not, recognized in the Einsteinian 4. Because it's the combination of the 4 and the 5 that creates the 9-dimensional reality as the juxtaposition of the 4 and the 5 that we know. So I'm going to talk about the subjective experience of the 5 dimensions now. There is an objective level of it, although to make it more complex, the 5th dimension itself, or 5th base, I'll call it, to signify really the 9th dimension, if we're counting up, the 5th base being the 9th dimension, if we add these on top of our familiar 4, that already is the subjective. It is the dimension of the subjective. And the 3rd base, or 7th dimension, counting up from Einsteinian dimensions, is the objective. So the objective and the subjective already have places, they already have dimensions of their own, so to speak, which makes it a little more complex. But in any case, we're not going to go into that. I'm going to wrap it up here. Next time, we're going to go into some more, the next Rave physics, we're going to go into the complexities of the actual 5 bases as dimensions. We're going to go into some of that material, and we're going to look at the bases. But I'll just say right now, just to wrap it up, the 5 dimensions that human design contributes, you can subjectively experience them. In the same way Stuart Hameroff says you experience quantum waveform collapse at the level of the quantum state of the microtubules in your brain that are producing a quantum state in the human. Very controversial statement, by the way. Most scientists believe quantum state only exists at 0 Kelvin or something, or extremely cold. Maybe not 0, but very cold. Far colder than humans could live. And so the idea of quantum state in humans is still very avant-garde, experimental to scientists. It's not accepted. But Stuart Hameroff, who's an anesthesiologist and loves to joke, you're all arguing what consciousness is. I'll lose my license if I don't know what consciousness is. I have to legally swear that you're unconscious before we operate on you. Stuff like that. As an anesthesiologist. Pretty funny. He's legally required to know what consciousness is. But in any case, he's a scientist and a researcher, and he studies microtubules and believes that we can subjectively experience quantum waveform collapse in the brain. So in that vein, when you're thinking of a lot of different things to say, you choose one to say, that's quantum waveform collapse. When you have a lot of choices and then the rest of them collapse and the one choice is made, that's quantum waveform collapse. But in any case, you can subjectively experience the 5 bases, and here's how. You start with base 5, personality. This is pure presence, and it's always present with one of the other 4 bases, right? Or it's present with the acoustic spatial phenomenon itself. Then you have base 1. You can be present with movement. Think of keeping your eye on the ball and swinging to strike the ball. This is opposite of the body. Base 3. You can't notice if you're hungry or if you're comfortable or not while you're keeping your eye on the ball. Movement and body consciousness are different. Consciousness of the body, being present with the body, is its own dimension. The dimension of pure presence of the body. It's a dimension. So is the dimension of pure movement, where nothing else exists and the movement is what it is. Like Neil Cassidy driving, talking about, hitting that jouissance. It's not his words, it's more like the, Lacanian term, but where you hit that fever pitch. The fever pitch. You can't be in the fever pitch and be aware of your body too. You can't be in the middle of that crazy jazz solo and then also be noticing your body. You do one or the other. You are present, and that's why it's so good when you're learning jazz, for instance, as a side note, to become present with the body, because you're constantly being pulled away from it into the movement, and it can actually be really helpful to put your attention and presence back to the body, to get in touch with your breath as a jazz musician, to get in touch with your posture, get in touch with your stage fright and all these body things. And then the other 2 dimensions are the 2 and the 4, and they're simply the design in the dream world, for instance, or the world of active imagination, or the world of images. That's the design. And then the world of mind, which is the world of remembering. And you can't remember and let yourself go into the world of images at the same time either. If you do a strong enough psychedelic experience, you will forget your name. You'll forget you're on psychedelics. That's because you've gone so deep into the design, which is opposite of the mind. You've left the mind behind. And so many people confuse this and for, awakeness and think that's what it's all about. And it's not. But anyway, base 5 or dimension 9 in our nomenclature is that pure presence. And then bases 1 through 4, dimensions 5 through 8 are these things that they each are their own dimension. Being conscious of whether you're hungry or not, the body's feelings, how the body feels pleasure or pain, that is its own dimension. The mind, what it remembers, is its own dimension. The design, the unconscious, the inner world of images is its own dimension. And so is the world of pure movement, which leaves all else behind. Thanks for watching.